podcast, we're going to be doing collision detection, and I'm going to try to do it really, really quickly. So go to ReggieNet, download the simple car OOP array list. This is a program that we made last Thursday. Go ahead and run it. Make sure that it runs. And it should look like this. And remember, this middle thing was our sort of frog. We called it a frog. And you should be able to move it up, down, right, and left. You could also use the same code that you had built already. That's totally fine. We'll notice that all the little swarm of objects have flown away, so we're going to have to fix that. And then also the little frogger thing is not moving very quickly, so I may want to change that to move a little bit more quickly. So the way we'll do that is in the main tab, and again, make sure that you open it clicking on Simple Car OOP Array List instead of the car.pde. If you click on car.pde, it's going to be a problem. So in the main tab, go down here. This is the key press routine. Also, look at, do you see how this is not formatted nicely? I'm hitting Command and T or Control T if you're on a Windows machine to format. That's under, it's under Auto Format. It's under Edit here. So Command T will format this a little bit better. And then also I'm going to take out this print line key code. There. So maybe change these to -15 and -15 here. +15 and +15. That'll make your frog move a little bit quicker. You can stop it and save it like I just did, and now it's moving a lot faster, so that's good. Okay, now to fix the swarm flying away, that is in the car class tab. So remember, that's here's our driving area here, right? And all we're doing here is adding the velocity to the position. Pretty cool, huh? The velocity could go any different direction, right? We've got X and Y components to our velocity vector now. And we don't even have to think about it because vector math is just done like this with this add command. Pretty beautiful, huh? So we need to do this thing, though, where if X is greater than width, X equals 0, and if the X component is less than 0, set it equal to width, because your things are going every direction now. Same with Y. If it's greater than height, you want to set it to 0. If it's less than 0, you want to set it to height. And you have a choice in this project. If you want, you can make this project, you can make it things just going horizontally or things just falling too. People have made games like that too. You don't have to use all the different components. In order to do that, you would set your velocity here. If you made this X component of your velocity 0, none of your cars or whatever you have flying around will have an X velocity, right? They'll just be falling. And then if you made this between random 0 and 2 or random 0 and 10, they'd only be falling down. So that's some options that you have for changing this code around a lot. So if the way you get to the X component of the position here is pos.x, position.x is greater than width, pos.x equals 0. So that loops it that way. Another if, pos, make sure you don't embed these all together. Some of you guys have done that before and gotten yourself problems. Okay, if pos.x is less than 0, pos.x equals width. And then you're going to do the same thing with y. So if you want, you can try to copy these lines. I'm not actually going to do it. I'm going to just type them out. If pos.y is greater than height, pos.y equals 0. And then if pos.y is less than 0, pos.y equals height. And I'm going to have to pause this. Save, play. So your little items, your little swarm should be looping now. Okay, so now we're going to add collision detection to this project. So in order to do that, the way that we're going to do this is we need to know how big every object is that you've got. So we're going to add, in the car class tab, we're going to add an attribute that's called wide, that it's width. We're not going to call it width because width is a reserved word here. Width is the width of your screen. So that should probably be a float. So float wide. And then remember, for every attribute we want to fill it in the constructor. So now you have a chance to vary how large your rects are, whatever you've got flying around, your hot dogs or your unicorns or something like that. So wide equals maybe random between maybe 30 and 60 or something like that. And then when you actually show your position now, you can have, or when you're actually doing your rectangle here, make sure you use your attribute, your width attribute. So here, look at that, wide, width, wide, okay? And that's kind of cool, huh? All right, so just adding that in here now into your display method here will determine how wide all your cars are. So go ahead and save this and run it. Look, some of my cars are wider than others now. Isn't that cool? So you can do this with the height also. Okay, and then my frog still works. Next thing we're going to do, so the methodology here is go back to your main tab, and in your draw routine where you're iterating through all your cars, this is where we're going through all our cars. We have 10 cars, it looks like. I starts at 0, goes till 10, and increments by 1. This is where we're pulling something out of our array list and sticking it into this temporary little variable temp car. This is where we're displaying the car. That means that corresponds to this display. Fill with its color and draw the rectangle. Then over here, this corresponds to the drive routine, which is to drive it, just like adding the velocity to the position and then deciding whether or not we need to loop its position or not. And then we're done, right? So for collision detection, what we want to add in here also. Okay, so as we're iterating through, what we need to do is after we display and drive every car, we're going to check its position in relation to our frog. And if the distance between each car's position and the frog's position is less than, say maybe its width, then we're going to assume that a collision has happened. So that's pretty easy to do here. So we'll make a variable called, like a temporary variable called d, float d. It'll be a floating point number, and it'll be each car's location, temp car dot location. Here's its location dot distance. This is how you figure out a distance between two p vectors, huh? This is a p vector here. Oh, actually, it's not location, is it? It's loc, probably. What did we call it? Oh, we called it pos. Okay. Dot pos. Tempcar.pos. Position. And the distance, and we need to know the frog location. We need a vector for the frog location. And actually, I don't think, did we use a vector for the frog? Oh, we did. Frog pos. Great. So, down here, distance between each car's position, that's each temporary car's position, and the frog position is going to be d. Then if d is less than temp car.wide, it's width. I'm going to just right now, I'm going to print line boom, just to tell me that I ran into a car, because I'm not sure what I'm going to do with it just yet. So do that, and then this at least should let us know when our frog has run into a car. So go ahead, let's save that and run it, and we should see boom every time car runs into a frog. So there, I saw boom. There's another one, boom. Lots and lots of booms happen when you run in, right? Because the distance is less and stays less than the width. Okay, so that works. Yay. So the next thing we need to do is we need to mark a car for extinction. If this particular car gets hit, we want to mark that it needs to be taken away. We're not going to just take it out of the array of cars, which is called my cars. We're not going to just take it out right now during this loop, because we'll run out of cars. It's like we're operating on cars, and we're going to destroy like the 8th car, and we're only on the 4th right now. When we get to the 8th, it's not there. It'll be a problem. So the way this works is we operate on all the cars. We make them drive, Then we test their location against the frog's location. And if they've hit, we mark them for like death. I'll have an alive bit as an attribute of each car, and then we'll mark it false. And then after we do this whole routine here, we're going to iterate through the whole car loop again and decide which cars to get rid of. So that's what we're going to do. So you should pause this right now and see if you can add another variable, another attribute to your car, and it'll be a Boolean attribute, and it'll be called alive. It'll be an alive bit, and we'll set it, we'll initialize it to true, because each car will be alive when it's first born. Okay, I'll let you pause it. Okay, I'm back. Did you do it? Here's how you're supposed to do it, actually. Boolean is the type. Now you should pause it and see if you can add. Okay, Boolean alive, and then here in the constructor, alive equals true. That's how you set this. A Boolean variable can either be true or false. So I'm setting it equal to true here. Okay, I'm not operating on it at all. In fact, I'm going to run this code just to make sure it works. Yes, it all works the same way. Okay, so now in my car tab, instead of print line boom here, I'm going to set this particular car's Boolean alive attribute to false. So tempcar.alive equals false. That will mark it for death. Okay, it won't take it out of the loop yet. Now the only thing left that we need to do is figure out how to actually delete something out of an array list. Okay, in order to get something out of an array list, it's a get, and in order to add, it's add. So how do we delete something out of an array list for my cars? And I showed this in a previous podcast. I'm going to show you guys this right now too. If I'm not sure how to do something with an array list, I might do this. Array list commands Java. Oh, look at this Java. Ooh, here are all the different things that you can do to an array list. So methods, you can find its size, which we've done. You can find out if it's empty, which is a Boolean, true or false. You can find out if it contains something. You can find out the index of something. But I'm going to look for delete. There's get, and there's set. There's add. I'm going to kind of, oh, look at that, remove. So you can remove, and the parameters it takes are the index of what you're going to remove. Okay. So you can also clear everything out. So remove here removes the element at the specified position in the list. This, I'm wondering what the difference is between these. Removes the first occurrence of the specified element from the list. That's kind of cool. So let's go back here to our code. And so we're going to do this again. We're going to copy these two. We're going to copy this line, so we can start iterating through our car list. Okay, then we're going to copy this. We'll get a temp car out. We'll test the car to find out if it's dead or not, and if it's dead, we're going to remove that particular car. So imagine this, we're going to go through, and actually we should not be using 10 here anymore. We should be using mycars.size. .size. Here too, mycars.size. Okay, so how do you think you check to see if a car is alive? This particular temp car. If tempcar.alive equals true, or sorry, equals false, then we're gonna kill it. We're gonna remove it. So remember, the command was remove. Cars dot remove. Which car? The ith car. Pretty cool, huh? And that should be it. Okay, so let's see if this works. Save, run. Oh, oh my goodness. I got a happy face in there. I have lots and lots of cars in here now. Looks like I think I probably changed it to have 100 at the top, but I was probably only drawing a couple of them. Yeah. The reason there's 100 cars in here now is look at this at the top. We had we were birthing 100 cars, but we only were iterating through 10 of them. So now that we have my cars.size, see, that's way more correct. Okay, so let's start with 10 cars just to make sure that we're killing them all off. Go ahead and run. See if you can eat up all your cars. So this is the end of this podcast. You could probably loop your frog around if you wanted to. And what you guys should be working on right now is you should be working on making something that isn't a box for your car. And you can even change the name of this, but you can also leave it the same. It's fine. But this right here in the display method where we have, this is the part I will change later, it's later. So change it. Change it to something interesting. Change your frog to something interesting. And this is probably due at the end of this week because you don't want to be working on it during Thanksgiving. All right. Have fun. We will have class on Wednesday.